Okay, so so okay, so let's continue. So we have these problems, part B. So let's try to solve question 1. So part 1 here, say integrate to x squared minus 7 dx. So this is very simple. We were supposed to use substitution method, but since this is more direct, so we just multiply this 2x throughout. So 2x multiplied by x squared, it will be 2x power 3. So just adding the powers. So x to the power n multiplied by x to the power m, same as x n plus m. So these are powers. You're multiplying the same variable x. So you can't say if it's m, y multiplied by power n multiplied by y to the what I mean is okay, so if you have this come on, okay, computer is tired. Okay, so we're here. So if you say y to the power n multiplied by x to the power m, here you can't add because these are two different variables. You have x and y. So what I mean is 2 to the power 2 multiplied by 2 to the power 3. This is same as 2. You just add the power since the base is the same. So it will be 2 plus 3, meaning to be 2 to the power 5. But you can't add if you have 3 to the power 2 multiplied by, let's say, 5 to the power 2. You can't, the base is different. So this is totally different. You can't add the powers. You calculate individually. So it would be 3 by 3, 9 multiplied by 5 times 5, 25. This is how you calculate. Okay. So 2x multiplied by x squared to be 2x cubic, then minus 2x multiplied by 7 to be 14x, and this is the dx. Your integration sign. So let me write here integration 2x to the power 3 minus 14x dx. So this is same as we can distribute the integration, same as this, integrating this and integrating this separately. So this is the same as integrating 2x to the power 3 dx minus integrating 14x dx. Okay, so 14 and 2, they are constant, so we can take them out. Okay, so you guys remember from our previous discussion on partial fractions. So you can say 2 integrating x to the power 3 dx minus 14 integrating x dx. So we know if we are integrating x to the power n dx, we add the power, so we say x n plus 1 over n plus 1. So you just add 1 to the power, then divided by the same addition. So this is same as 2. So write 2 outside, which is here, then open bracket. So x has a power 3, so we say 3 plus 1 over 3 plus 1. This is the first part, minus 14. This x has a power 1, so we say x 1 plus 1 over 1 plus 1 plus c. Okay, so this is same as continue writing 2. This will be x1, this is 3 plus 1, which is 4, over 3 plus 1, which is 4, minus 14, 1 plus 1, 2, over 1 plus 1, 2, plus c. Okay, so now you can 2 and 4 are divisible, so 2 into 2 1, 2 into 4 we have 2, so it will be x to the power 4 over 2 minus 2 into 14 is what? 7, x squared plus c. So this is your answer. Simple and straightforward. So this was a direct application of the basic formula for integration. Okay, so let's go to part. Let's see which one we can solve. Okay, so let's first solve 4. Let's solve 4. Okay, so let's go to part 4 first. So part 4 is integrate 10x dx. So we know tangent 10x is same as sine x over cos x. So let's quickly substitute that. Say tan is same as sine x over okay, cos x, then there is dx. So here we can use the quotient rule. So the quotient rule, how do we use the quotient rule? If you're dividing your, for example, u over v, if you're dividing this, if you are integrating this, your answer is same as everything divided by v squared, then you have u prime v minus v prime u. Okay, so this is your formula. U prime, this u, then v minus v prime u. So v prime, u prime is same as the differentiating the equation. So it's same as the du dx, same as du dx. It's a differential. Then v prime is dv over dx. Okay, so you can apply this formula. So we know u is, so we can say u is a numerator, so u is equals to sine x, meaning if you differentiate this, meaning it will be u prime. If you differentiate sine, it will be what? Cos x. This is the numerator. Then denominator v. V is equals to cos x. V prime is a you differentiate cos. So if you differentiate cos is what? Negative sine x. So now we substitute in the formula. So I'll repeat the formula. So sine x over cos x so we have u prime is what? Cos x. Then you're multiplying by v. What is v? V is cos x. Then you say subtract v prime. What is v prime? Negative sine x multiplied by u. What is u? U is sine x over what is v? It's v squared over v squared here if you follow this formula here. v squared. So v is cos. So cos squared x. Okay, oh, I just write it like let me write it like this. I don't want you guys to say you are lost. So cos x squared. So this is direct application of the formula, the quotient rule. So the quotient rule. So sine dx is equals to, so sine multiplied by cosine multiplied by cosine, it will be cos squared x. Negative by negative, it will be plus. Sine by sine, negatives, I mean sine squared x over cos squared x. Okay, so we'll continue, right? So we know from the circle theorem, the unit circle, you guys, if you remember very well, if you have a circle, the radius r separated by the angle theta here, if you use your SOHCAHTOA here to find this distance and this distance, so you are forming a triangle like this. So you're forming a triangle like this. So this is r, this is theta. So this is your x, this is your y. From SOHCAHTOA, if you want to find x, what is x in relation to this angle? So x is adjacent. X is adjacent. So our hypotenuse is r. So if you use cos, for example, cos theta, adjacent is x over hypotenuse is r. So you have x equals to r cos theta. Same applies if you want to find y. Y is what? Opposite to this angle. So sine theta equals to y over hypotenuse is r. Okay, so you will find that for y, here is over 1, so you cross multiply, y it will be equals to r sine theta. Okay, so we have x equals to r cos theta, y equals to r sine theta. So if you remember very well from Pythagoras theorem, so we have this distance r sine theta, then we have r cos theta, then we have the distance r. This is theta. So if you want to calculate the hypotenuse, how do you calculate the hypotenuse? You take squares of adjacent and the opposite. So r squared is same as x squared plus y squared. So x squared, we know x is r cos theta. So r squared equals to r cos theta squared plus y is what? R sine theta squared. So we have r equals to, so this will be r squared cos theta squared multiplied by r squared and squared theta. So you know you can take out or factorize r. So you have here, you have r squared equals to r squared, here there will be cos squared theta plus sine squared theta. So r and r and r can cancel, so here there will be just 1 equal to cos squared theta plus sine squared theta. So this is the identity. So when you find cos squared theta plus sine squared theta, you can just substitute this with the 1. So it can be cos x, for example, y plus sine squared y. Same answer will be equal to what? 1. So coming back to our equation, here on top here it will be just 1. This is the identity which you guys have to know. So cos every time you see this, you just substitute 1. Okay, so I've shown you how to derive it. Okay, so on top we'll just have 1 over cos squared x. So again, from trigonometry, you know 1 over cos x is what? Sec x. 1 over sine x is cosecant. So this one is cosec x. So you just have to know some basics. 1 over tangent x, you know, is cot. Yeah. So 1 over cos is sec. So this will be sec squared. So this will be sec squared x. So that's the answer. So I'll write it here. Integral of tan x dx is equals to sec x plus c. Don't forget. Okay, so this is part 2. This is our part 3. Okay, so we'll cut this video and continue later. Okay, thank you for watching.